Howdy folks, welcome to Module 3 of the CompTIA IT Fundamentals course, or should I say ITF Plus course. Now today's module, guys, consists of 5 units, a bit more than the previous one. So in case you guys are wondering what those 5 units are, here they are for you guys listed out. The first unit is system components. So here we're going to be talking about various components that you would find in a computer. The second unit is going to be using device interfaces, followed by unit 3 using peripheral devices. Then we'll move on to unit 4 using storage devices. And lastly, folks, unit 5 using file systems. All right, guys, there you've got it. That's going to be the 5 units we're going to be covering in this specific module. As I've said before, that on its own does not exactly tell us what's going to be in this module. So if you want a more accurate list or idea of what's going to be in this video, you can find that in the video description down below, where I've added nice convenient timestamps for you guys to go and use as well. So if you guys are looking for something specific in a video, maybe you just want to go and recap on something specific, those timestamps are there to make your life easier so you can find what you're looking for a heck of a lot quicker. Alright folks, and then before we jump into that first unit, if you haven't done it already, do your homie here a favor, give this video a like. It really does help the video, it promotes the channel. This video is going to pop up on more people's screens, which means we get to help more people out there that can't afford to pay for study material. And then folks, if you find this content interesting, or if you find it useful in any way or manner, maybe consider subscribing as well. At least then you'll know when the next module comes out. Alright guys, now that we've got that blah blah out of the way, let's go learn something. Alright folks, let's jump into that first unit, which was system components. The first topic I've got for you guys in this unit is something called network interface. Now for those of you not familiar with this is what allows your computer to be able to communicate over a network. Now, in case you didn't know, you get two kinds of network interface cards. Yep, cards. One allows you to go and plug a cable into your machine. So that's mostly going to be your desktop computers, the one you would put on a desk, those ones with a big screen and a big keyboard and a big box, those. Then you get a kind of network card that allows you to connect wirelessly to a network. Now you'll find on average, generally just laptops have that capability, but it does not stop you from adding that to a desktop computer. Now starting with wired network, the more common one out of the two, this consists of an Ethernet port, which we call an RJ45. So the back of your desktop computer, that's the one with the big box, or even on the side of your laptop, guys, there's a port where you would go and input the network cable. We commonly refer to this as a LAN cable, but it can also be called an Ethernet cable. And that little connector that you go and put into that little jack, that is an RJ45 connector. And the port in which you put it, that little jack, that's an RJ45 port, folks. So now that jack is actually the same for all network cables when it comes to LAN cables. So it does not matter whether we're talking about Cat5, Cat5e, Cat6, Cat6a. It doesn't matter. They all use the same connector, which is an RJ45. Now, for those of you that's probably very confused right now, wondering what the heck is Cat5 and Cat6, those are categories of cables. So Cat5 means category 5. Cat6 means category 6. You get various kinds of cables. So as time goes by, the category number keeps going up and up. The cables can handle more data. They become faster and faster. So at this point in time, at the date of making of this video, I think the most common kind of category cable you'll probably get is around Cat6, Cat6a, those kinds. But you will from time to time still find some businesses and homes that still are using Cat5, Cat5e, which are the older versions of network cables, which are obviously much, much slower. Now, as for these Ethernet cables and RJ45 connectors, guys, they slide into a port, yes, on the laptop or a desktop. But that's not just a port. That, believe it or not, guys, is actually your computer's network interface card, more commonly known as a NIC for short. So for any of you guys that needs to perhaps go and write the exam, maybe you want to go and write the international exam associated with this course, they're going to refer to this as a NIC. So if you see this in the exam, maybe it's listed as an answer, maybe it's mentioned in the question, please just know that NIC is short for Network Interface Card. Now the network interface card can be a wireless one or it can be a cable one, a wired one in other words. In this case we're talking about a wired one. Now besides a wired network folks, you also get a wireless network, which means there's no cabling involved. For the most part, this is probably going to be only your laptops, but a desktop does have this capability if you just go and add the correct hardware. This is normally going to be adapter cards, and these adapter cards will give your desktop computer wireless capability. We normally don't do that unless we absolutely need to. So wireless networks, folks, they work with Wi-Fi radio networking. So these are various Wi-Fi frequencies. There's many kinds. I think the last time I checked, there was about 6, but they're constantly releasing new ones and new ones and newer ones. The last one I believe was released in 2021 during COVID. So that was 802.11ax. That was the most recent one. We also call these standards, just FYI. Now, speaking of wireless and wireless frequencies, something else I can mention here for you folks is wireless access points, or just access points for short. And sometimes we just call these even APs for short. AP, which is short for access point. If you don't know what that is, guys, that's a device which allows you to access your network wirelessly. Now, if you have a small home or a small office environment, you 10 to 1 don't need these because your router in your home or your office normally has wireless capability and you'll probably be close enough to it to be able to connect to the network wirelessly. But as soon as you start having a big home or a big office, you most likely might be too far away from that router. The signal is going to be too weak or you're not going to detect it at all. Now, in such a situation, what we could go and do is you could go and take a network cable from the router and you can go and plug it into an access point. It looks like a router, but it's literally just a device that takes the signal and makes it wireless. So whatever network you've got on that cable, it's literally just going to take that and broadcast it wirelessly in a different part in your home or in a different part in your office. Basically, in short, it's going to go and extend your network, folks. Right, folks, moving on to the next topic, motherboard components. We're going to do a bit of a hit and run on some of these topics. We're not going to go too deep, only deep enough to the point what you guys need to know for this course. But if you find this interesting, if you'd like to know more about this, I definitely encourage you guys to go and maybe look at an A+ course. I happen to have that on my channel as well. So if you find this interesting, go check out the CompTIA A+ course on my channel. But yeah, I mean, this should be enough for you guys to be able to pass the exam if that's your intention. So I've got a bit of a motherboard picture there for you guys. It's not the best, but it should do for now. Now looking at the motherboard, you'll see there's a blue block top left that says CPU socket. If you look at where the arrow is pointing, that is where your CPU goes, guys. Your CPU is your central processing unit. That's what the abbreviation is short for. Now, many moons ago, the CPU, which is actually the main brain of your computer, it actually used to be in the middle of the motherboard, like legit in the middle. It used to not necessarily be a chip, it was actually a card that you have to go and slide in. And as time went by, the motherboards obviously changed. It's no longer a card because those cards, the channels just couldn't handle speed anymore. So nowadays, it's going to be a chip. It's still in the middle if you have to look at it from left to right. But if you look at the board from top to bottom, it's not really in the middle anymore. It's more towards the top. But in a nutshell, guys, that is the brain of your computer. Now, on the right of that motherboard, you'll see there's one that indicates memory slots. Now, in this picture, we've got 4 memory slots. But if you go look at the average standard motherboard, guys, it's normally about 2 memory slots you'll have. This is also known as your system memory. It is also known as your RAM, which is actually short for random access memory. It's your computer's temporary memory. So whenever you open a program, a game, or a document, it's going to take that program, game, or document, whatever it might be, from your hard drive, which is permanent long-term storage. It's going to load it temporarily into your RAM, and then you'll be able to see it on your computer and work on it on your computer. And as soon as you close that document, that program, or that game, it's going to remove it from your RAM. Now, way on the right of this motherboard, guys, we've got something called disk drive connectors. Now, this one, I can see there's about 3 of them in this picture. With this one, it's going to be SATA cables, SATA cables, which you're going to be plugging in from the right. But you'll find it's actually more common to find these cables plugging in from the top, not the right. If you see them plugging in from the top, that's actually not such a good thing depending on where they are on the motherboard, those ports, because it's actually going to obstruct other components like your graphics card. If you find yourself a motherboard like this one, where you're able to plug them in from the side, then you've got yourself a good motherboard because the cables are not going to be in the way. So those SATA cables, guys, that's going to plug into your optical drive. So if you happen to have a DVD or a CD-ROM drive, not that anyone has those anymore these days, but if you happen to have one of those, that's where you would plug one in. If you have one or more hard drives in your computer, that's where you would plug them in. It doesn't matter if it's a solid state hard drive or an old school mechanical type hard drive. Not that you need to know what that is at this point in time. It doesn't matter. That's where you're going to plug those in. Now looking at the indicator at the bottom of this picture which says adapter card slots. That, folks, is where you're going to go and insert your expansion slots, giving this computer additional functionality. And if you look at the top slot there, which is light gray, there's two arrows there for adapter card slots. The top one, which is a light gray, that is your PCIe slot, which is short for PCI Express slot. That is where you would go and insert your graphics card, an external graphics card. And depending on the specs of that graphics card, that'll dictate, what kind of games you can play and what kind of performance you'll have on this machine graphics-wise. If you look at the other slots there, those are just normal PCI slots. Some of them are PCI times 2, some of them are PCI times 4. That's basically just the speed of these slots. And that you would normally go and use for sound cards, internal modems, basically anything weird like that where you want to go and give your machine additional functionality, guys. Right, folks, and if you look at the last one where they're on the left, I/O ports, those are input-output ports. So that's ports that allows you to go and put information into your machine and for you to extract information out of the machine. So input would be something like a mouse or a keyboard. Output would probably be something like a speaker, headphones, printer, those kinds of things. So we're going to cover those more in depth later in this video. So for now, just know that is where you go and plug things into the motherboard. So either input information into your computer or to extract information from your computer. So if you go look at something like your computer monitor, if you plug that into the computer monitor port, that's going to be output because it's going to output the information onto your screen. Alright guys, moving on, moving swiftly. Next topic, system cooling. Now like most kinds of electronics in life, we need to keep computers cool. How you do that? That's up to you. You can do it the standard way, which comes from the factory, or you can go and change it afterwards, kick it up a notch. Now normally if we go and change the way we do this, it's normally because we want to go and do something like overclock a machine, which basically means we send more power to things like the CPU. But in turn, more power equals more heat, which means the standard cooling is just not going to cut it. But let's keep this as much to the book as we possibly can. So the first thing we're going to talk about under system cooling is heat sinks and thermal paste. Thermal paste, guys, can also be called thermal compound. Sometimes it's literally just called heat paste, just FYI. It's got lots of names. So what is the heat sink? Now on top of that little CPU slot that I showed you guys earlier on the motherboard, on that slot, or in that slot, you're going to go and insert the CPU, which is the central processing unit. It's a chip. It's your computer's main brain. Now, on top of that chip, you are going to go and put what we call a heat sink. Looks like a giant big metal block. It's normally made out of aluminium because aluminium absorbs heat very well, but also stays cool very well. You'll be surprised to know a lot of spaceships are actually made out of aluminium as well because they stay cool upon entry, when they come through the atmosphere. It absorbs heat well, but also stays cool well, which is exactly what you want when it comes to spaceships. Yeah, go figure. Now, on its own, the aluminium is not going to absorb the heat from the CPU very well. Now, that, guys, is where thermal paste comes into play. And if it's a brand spanking new CPU, it actually comes with the heatsink and the fan, and the heat paste is actually pre-applied from the factory on the heatsink. You just need to go and plug it in. That's it. But if you're going to go and change the CPU or clean the CPU or change the fan or change the heatsink or anything in that matter, you're probably going to have to go and reapply the heat paste manually. Comes in a little tube, looks like a toothpaste tube, I kid you not. Sometimes it comes in a little syringe. You can go and remove the old heat paste if there is any, and you're going to squirt it on just a little bit onto the CPU, basically the size of your pinky nail. Put it in a little circular fashion, and that should be good enough. Now, if you don't know what that is for, it is to basically help aid the CPU in transferring its heat into the heatsink, because on its own, it's not very good at doing that. I mean, yeah, it is going to go and transfer heat, but not very good. So the heat paste is to allow it to transfer the heat just so much more efficiently. Now on its own, the heatsink, yes, it is going to absorb the heat, and obviously even better so if it's got thermal paste. But to help aid in cooling it down even further, that is where the CPU fan comes into play. So normally on the side of this heatsink or on top of this heatsink, you're going to have a fan blowing over this heatsink. And if you go look closely at the heatsink, you'll see it's got these fins, these little blades, which allows the air to blow between these blades, cooling them down. Pretty cool, wouldn't you say? Now, with regards to heat sinks and thermal paste, guys, you get something called passive cooling. Passive cooling is something that takes place, quietly for the most part. So that would be something like a heat sink. A heat sink doesn't make any noise. It absorbs the heat and cools down the CPU quietly. It doesn't make any noise. When you get active cooling, which is normally a fan or something, that cools down the machine in some sort of way, but it makes some sort of racket, makes some sort of noise. Now, under passive cooling, I also want to mention something like transfer heat by convection, something we did actually talk about. So that would be the heat sink that you put on top of the CPU, which absorbs the heat and transfers it into the heat sink, obviously cooling down the CPU. Then I want to talk to you guys about fans. So that would be an example of active cooling, or should I say powered cooling. This dissipates warm air from the components like the heatsink by blowing air through the little vents for those little blades. Works almost in the exact same concept as your car's radiator. So when you drive your car, the radiator obviously, it cools down the water in the engine. But how does it do that? It does that by air blowing in from the front of the car through fins or little blades, and that obviously cools down the water inside the radiator. It's very much the same concept, folks. Now, the case fans themselves, I'm not talking about the fans you would find on the motherboard, guys. Your computer's case, if you go look at something like a desktop computer, it's actually got fans at the back of the case, it's got fans in the front of the case, and sometimes even fans on the side of the case. Some of these fans are used to draw air into the case, cool air, and some of them are used to push air out of the case, which is normally hot air. So normally cool air is drawn in through the front of the case, and hot air is pushed out at the back of the case. So you can go and change this if you want to, but as long as you just make sure that some of the fans are going to pull air in, and some of them push air out. You don't want them to all pull air in or all of them blow air out, because then it's just going to be counterproductive if you think about it. And then one last thing I want to mention to you guys, I mean, why not, is you get something called liquid-based cooling systems. This is not something you'll find on your standard PC. This is something you'll find normally aftermarket. So if you are a tech geek, a gamer, or a tech whiz, you're probably going to go and change your gaming computer. I mean, but it obviously depends on whether you've got the money to do this as well. Just because you know how doesn't mean you can. I mean, funds is obviously going to be an issue. But if you can, you would be removing the heatsink on top of your CPU. You're going to remove the fan, the heatsink altogether. You are going to go and put something like the picture we see in front of us. So if you look at the CPU top left, heatsink is removed. There's no fan. Instead, we've got what we call a water block on top of that CPU. So you can imagine that CPU being your car's engine. That's where all the work takes place. But doing so, the engine obviously generates a lot of heat. Now, in case you guys didn't know, your engine actually has water in it, which gets pumped through the engine with the water pump. It pumps in cool water into the engine, and that cool water will now in turn absorb the heat from the engine, and then the water pump pumps out the hot water out of the engine to the front of the car to the radiator where it gets cooled down again, and then that cooled down water gets pumped back into the engine. Now, this concept we see in front of us works actually in the exact same principle, in the exact same way. So the CPU would be your engine. That's where the water is going to get warm. It pumps out to the back of the case. You'll see if you look at the right of this picture, there's two fans there. That is the radiator. I kid you not, it's actually called a radiator in the computer. It goes to the radiator where it gets cooled down again, and then it gets pumped back to the CPU. Now, right in front of those two fans, you'll see there's like a little bottle there. I know it's a little blurry. Looks like it's got white liquid in it. That is your water storage. Or should I say your water bottle or your reservoir. I think the actual name they use is a reservoir. Your car's got the exact same thing, folks. So when you want to go and top up the coolant in your car, some people just go and throw water in there. Some people go and throw an antifreeze in there. When you top up the coolant, you normally throw it into the what? The reservoir. I kid you not. So there's a lot of similarities between this and a car. Who would have thought, right? Alright guys, so that concludes the first unit in this module. Let's move on to unit 2, which is using device interfaces. Alright guys, first topic in this unit, computer port and connector types. And on that note, here's a nice little picture for you guys so you guys can see what the heck I'm talking about. So that, in case you guys don't know, is a picture of a motherboard, or at least a part of a motherboard. I've got a bit of indicators on the left showing you what is what. Now keeping in mind, motherboards are not all the same. So my motherboard, for example, will not look the same as your motherboard. But you will more or less find the same ports, just not the same amount and just not in the same place. Now starting at the top, if you look at the first one, it says HDMI. Now those are mini HDMI by the looks of things. They could possibly be the standard size. They could possibly be the mini ones. Either way, that's HDMI. So that's high quality 4K video, which can also transport audio. Then we've got DVI. Now if you look at this picture, I happen to see two. These two DVI ports, that's for graphics guys, digital graphics. Those two are embedded on the motherboard. So those ports are actually physically mounted on the motherboard. Now if you go and, expand your motherboard with an expansion card, which happens to be a graphics card, that means you would be sliding it into that PCIe slot we spoke of earlier. Now those graphics cards, they may or may not come out of a DVI port as well. The newer ones don't actually come out of those anymore because that's seen as old technology. But if you happen to have a relatively old graphics card, then you might actually still see those old white ports. Next, we also have SATA. So that is if you want to go and connect an external SATA device. Not something we do that commonly, but can happen. We've got USB. I mean, show me a computer these days that does not have a USB port. You're going to have a hard time finding one because all machines have got USB port. The question is how many and how fast. Now, in case you're wondering, what do I mean by how fast? Well, guys, not all USB ports are the same. They will generally work, yes. If you go plug one USB device into another, yes, it will work. But you will not necessarily get the maximum speed. So if your port is very fast and the device is slow, the slow device obviously is going to bottleneck the port. If the port is very slow and the device is fast, then the fast device is going to be bottlenecked by the port itself. So either way, if you want to get the true blue speed of your USB port, you need to use the correct device on the correct speed port. Now, normally if it's a black port, it'll either be 1.1 or 2.0. Nowadays, it'll probably just be 2.0. You don't really get 1.1. Those are kind of extinct. So 2.0, that's about roughly 480 megabits per second at which it will transfer. If it's a blue port, we consider that USB 3. Nowadays, you also get USB 3.1 and so on and so forth. Much, much faster, but the way you identify these is because it's blue inside. The same with the USB 3 devices. Normally, not always, it'll be blue inside the USB connector itself. Then, guys, the second last one on this picture, RJ45. Something we did speak about earlier, so that would be your network cable. Now, unfortunately, these look the same in this picture. It looks like there's two RJ45 ports, which is a bit unusual. Normally, you'll only have one. But an RJ45 port will look something like that. Feel free to go to Google and Google what RJ45 connectors looks like and what an RJ45 port looks like. Then you'll know exactly what I'm talking about. So that, in short, is your network cable port. So it's going to be your LAN cable, in other words. And then the last one on this picture, folks, is the audio ports. In this picture, we happen to have flippin' 6 of them. Normally, you only have about 3 of them. Your green one, which is normally your audio. The green one almost looks like yellow or like white here in this picture. You'll have your green, which is your audio. You'll have your pink, which is your mic. And then you'll have the blue extra one, which you can go and choose what you want to go and do with. If you've got anything more than that, well, consider yourself lucky. But in reality, you actually just need 3. If you really are clever about it, you can actually get away with just 1, to be honest with you. Moving on to the next topic, Universal Serial Bus, better known as USB for short. So you guys probably know this as USB for short, but a lot of people don't actually know what it stands for. And believe it or not, it actually stands for Universal Serial Bus. And before you wonder, no, you do not need to know that for the exam. You just need to know what USB in general looks like, what kind of cables they are, that kind of stuff. You do not need to know what the abbreviation stands for. If you do, well, great. That's a bonus. So guys, with regards to USB, there's a bit of a picture for you guys of various kinds of USB cables you get. I do, however, want to make it clear that that's not all the USB cables you get. Those are simply the most common ones you get at this point in time. There are, however, a couple of newer ones, which they won't ask you about in the exam, but there are a couple of newer ones on the market as well. All right, so these USB cables, guys, they are generally plug and play. That generally means you plug whatever this is into a respective port, and whatever this is, it'll normally work immediately. You don't have to go and restart your computer. You don't have to go and restart the device you've just plugged in. You don't have to go and install drivers. You literally just take that component, whatever that device is, plug it into the USB port, and voila, it'll work. That is what they mean by plug and play. USB usually is plug and play. And with a lot of cases, you'll notice USB actually supplies enough power for small peripherals. So if this is a small device that doesn't have its own power or its own battery, or the battery happens to be flat, it'll actually have the ability to power up that small device, or even in some cases, charge that small device. I mean, a phone would probably be a very good example. If you happen to have a USB cable for your phone, and you plug it into your laptop or desktop, and you plug the other end into your phone, you'll notice it doesn't just connect your phone to your computer, but in a lot of cases, it actually even charges your phone. I mean, how about that? Now, guys, with regards to these 5 kinds of cables we've got in front of us, probably don't need to go that deep, but if you look at the one on the left, that's your standard USB cable. Second one from the left is not something you guys will see that commonly, and it actually is becoming less and less common by the day. I think the most common location you guys will probably see this these days is behind a printer. So if you happen to still have a printer, it works with a USB cable, a cable that you plug directly into your laptop or desktop. That is what the USB cable will look like at the back of the printer. The front of the cable, the part that plugs into your PC, will probably be that picture way on the left. Now, looking at the cable way in the middle, that is something you'll find maybe like on a car's dash cam. If you've got a digital camera, an actual digital camera, you'll probably find it in those kinds of devices. Second cable from the right, that's more like a phone charger kind of deal. You do find those on other devices as well. Just before USB-C became popular, that was probably the one just before USB-C, if I have to put it that way. And then the one on the right, man, do I need to even say it? That's your standard USB-C, which pretty much most phones use these days, and a lot of devices use these days. I mean, if you've got yourself a vape or anything these days, almost everything and anything uses USB-C. It's actually quite weird if you find something that doesn't work with USB-C these days. Alright guys, moving on. Graphics devices. So in other words, what I'm actually saying here is a graphics card or graphics adapter. Do laptops have them? Yes, quite often they do, but if you happen to have a laptop that happens to have one of these cards, you can expect to pay a heck of a lot more for that laptop. And unfortunately, in most cases, you cannot go and upgrade or change the card afterwards. The only time you can change the card afterwards is if you happen to change it to the exact same card because the previous card failed. And generally, it's not worth it. It's normally more worth it just to go and replace the whole laptop altogether. And a desktop PC? Well, yes, you can go and upgrade. You can change as much as you like because you've got nothing but room to play with. Space is key here, guys, because if you go look at a laptop, they don't natively have a lot of space to work with, which is why we can't just go and swap and change graphics cards of whatever we want to. We can only put in the exact same card or something smaller, physical dimensions wise, because we don't have a lot of room to work with. And if you happen to get yourself a laptop that's got the same specs as a desktop PC, I can tell you now that laptop's going to cost you almost twice as much, if not more, because, well, that's laptops for you. Anyway, getting back to the actual topic here. So with regards to graphics devices, video card or graphics adapters which generate the signal to send a display device. So that is going to be the signal coming from your laptop or desktop, and it's going to come out of the port of the graphics card, and that's going to allow it to display onto a screen of sorts, which is going to be your monitor. Most motherboards, not all, but most motherboards have an integrated graphics adapter. So if you look at a laptop, most of them have got an onboard graphics card. We don't call it integrated so much more than onboard graphics cards. And if you look at desktop computers, this is actually becoming less and less popular by the day. But you still get them. A lot of these motherboards actually have a built-in onboard graphics card. It's definitely not the world's best. If you want to go and do basic office work and what have you, you should be just fine. But as soon as you want to do something a little bit more graphics intensive, like playing games or what have you, maybe you want to do some rendering for graphics and arts and design, anything in that nature, yeah, you're going to have to go and change that onboard graphics card, or at least upgrade it with an external graphics card. Then guys, these graphics cards provide high performance, so they are high performance adapters which can be fitted through an expansion card. Which slot do we slide them into? Can anyone remember? That would be the PCIe slot on the motherboard. Most motherboards will have one of those slots, but it's not uncommon to find a motherboard with two or sometimes even three or four of these expansion slots. If you've got 2 or 3 or 4 graphics card slots, guys, you're going to be paying a heck of a lot more. Those motherboards are not easy to come by. They're not cheap. You're basically going to have to go and sell a sibling to be able to afford these motherboards. So those are only for true blue gamers that want to have 2 or 3 graphics cards in at the same time. My honest opinion, it's not worth it to have 2 or 3 graphics cards because you normally have to preferably get graphics cards which are slide compatible. Not something you guys need to worry about. These graphics cards have to be slide compatible. That kinds of stuff, and you generally want to try and get 2 cards that's the same. I'm not saying it's a rule, but you want to try and get 2 of the same card, both preferably slide compatible. You would actually be better off spending a little bit more money on one card and one card only, which is not necessarily slide compatible, and that's actually going to save you money and you're going to get higher performance out of it. Not something I'd worry about at this point in time though. Now, also what I want to mention, video cards often has its own CPU. Now, unlike the actual chip on the motherboard, we don't call it the CPU normally. You know, the chip on the motherboard, that's called your central processing unit because, well, it's center. The one of the graphics cards instead called your GPU for graphics processing unit. Believe it or not, these things are very often way more powerful than your CPU. Yeah, who would have thought? And these graphics cards, guys, actually come out of their own memory. Very often, way more than what your PC would have. So a graphics card is actually sometimes way more expensive than your whole freaking PC, simply because of the performance it actually outputs. That was not always the case, but now currently where we are at this point in time, it's definitely not uncommon to find a graphics card cost as much as a whole PC altogether. And then lastly, guys, pretty much all graphics cards these days, well, at least all the decent ones, they will provide you full HD, or should I say 4K resolution. Unfortunately, you will not always reap these benefits unless you've got a proper screen. I mean, it's one thing to have a graphics card that puts out 4K resolution, but you go and put it as on a normal, cheap 19-inch monitor, then you're not going to get the full specs out of that. You know, really not. You're just going to get your standard resolution. Alright, folks, moving on to a more specific type of cable, something we did briefly touch on earlier when we looked at the motherboard, and that is high definition multimedia interface. Wowza! Try saying that 3 times fast. So in other words, we just call this HDMI for short. Okay guys, so in case you don't know, yes, we did cover this cable earlier, very widely used on computers, but not just computers. Also consumer electronics. I mean, that sounds very fancy when I put it like that, but in essence we mean you can go and plug it into things like your TV and anything it can display. It can potentially even be a projector for all we know. So you can go plug the one end of this cable into your TV, your projector, a big fancy monitor, and the other end you can go and plug into something like, well, a computer, your laptop for instance. Now, we did mention that these cables are able to transfer not just video in up to 4K, but they can also transfer audio. One of the very few cables out there, I wouldn't say it's the only one out there, definitely not, but it's one of the very few cables out there that are not able to just transfer video, but in fact also audio. So it's got sufficient bandwidth for HD and 4K resolution, not to mention the audio side of things. It's got mini and micro connectors also available. So the picture I showed you guys there looks more like a standard kind of HDMI. And that little motherboard I showed you guys earlier, which was more of an animated motherboard than anything else, those look more like the micro or mini HDMI ports. So it's the same thing as just a mini port because everything is getting flippant smaller these days. Now guys, there is a pretty good chance you are going to get a question about this in the exam. This cable, amongst one other cable, which is called a DisplayPort cable, both of these cables are able to transfer both video and audio at the same time. That's the kind of question you can expect in the exam. They'll ask something along the lines of which of the following cables are able to transfer or communicate with both video and audio at the same time. It's normally multiple choice questions in this exam. Almost all your questions for the most part will be multiple choice. They will ask you a question like I just did. They will present you about 4 possible answers of which you can only choose one. And in this instance, your answer is going to be either HDMI or DisplayPort. Now, in case you're wondering, but which one do I choose? Well, guys, they will only list one of the two I just mentioned in the exam, either just HDMI or just DisplayPort. Well, they will normally not list both of them because they're technically both correct. They both achieve the same goal. Now, speaking of DisplayPort, here is that cable for you guys. So DisplayPort at first glance looks very much the same like an HDMI. But if you look very closely to that little connector port in which it slides, you'll notice it's not the same. It's definitely not the same. So this, guys, is competitive technologies to HDMI. It's basically the opposition, the enemy, or just good old-fashioned competitor. Why was it designed if it's so much the same? Well, guys, with HDMI, if you are the manufacturer for something that uses HDMI, let's say you are manufacturing graphics cards, anything like that, if you've got HDMI ports on there, believe it or not, you've got to pay royalties. Yeah, whenever you use some technology like that, whoever invented that, you've got to pay royalties to those guys. I mean, that sucks, right? So a lot of people said, no, enough of that. We don't want to pay royalties. So instead, I'm not sure who, but some clever bloke out there came up with this great idea of designing their own port, their own cable, which does the exact same thing as HDMI, except, well, it's free. It's free to the public. No royalties. And to prevent getting sued, they made the port look a little bit different and the actual cable connector look a little bit different. But it does the exact same thing as HDMI. It's new technology. No royalties involved. You absolutely don't need to know that. That is just a little trip down memory lane so that you know why it was actually designed in the first place. Pretty cool, don't you think? And then also something quite interesting about these DisplayPort cables, folks, is they do actually in fact support daisy chaining monitors. So that means you can go and connect 2, 3, or 4 monitors together with these, well, DisplayPort cables, all together on one video stream. I mean, how cool is that? That's really funky. So if I need to have 3 or 4 monitors on the same video stream, that can be really useful. I mean, it's not something you do that commonly, obviously, but still, when the need arises, that'll certainly going to help me out. Right, guys, and then we've got VGA and DVI. I did actually mention DVI briefly earlier when I showed you guys that picture of a motherboard. And here we will probably be able to see a little bit better what DVI actually looks like. So starting with VGA, which is short for Video Graphics Array, you don't need to know what it stands for. You just need to know the abbreviation is, well, it's VGA. You just need to know that it's video. Now, VGA, guys, is in fact actually analog video signal. And it probably is still this day, probably the most common kind of video cable we use. If you go look at behind the standard computer monitor in the standard office or home environment, I bet you're probably going to find a blue port there. I bet you that's probably what they're using. And I bet you that's what they're using to display video from their computer to their screen. Analog is in fact still the most common one. But that's very old technology. We refer to that as legacy technology. Now DVI, in case you don't know, that is short for Digital Visual Interface. Also not something you need to actually know. You don't need to know what it stands for. You just need to know that it's digital. So VGA is analog video signal. DVI is digital video signal. Now, even though it's digital, I can't go and say that this is new because it's not. That's actually also old technology. It's also considered legacy technology. Legacy simply means something is old. So by now, you should see both of them on the screen. The one on the left, that's VGA, the little blue port. The one on the right, guys, that's DVI, the white port. Now, you might still find these from time to time behind some computers and some boxes and some screens. But they are being phased out and they are being replaced by things like HDMI, DisplayPort, mini HDMI, and so on and so forth. Alright guys, let's talk a bit about input devices. So that is devices that allows you to input information into your machine like your computer. Examples of this obviously be a keyboard and a mouse. I mean, it's not just limited to those two, but that's probably the two most obvious and the most common kinds of devices we would use to input information into our respective machines. Now, starting with keyboard, this could be USB. Probably the most common kind is USB. I prefer good old-fashioned USB. But keyboards do also come forth in Bluetooth nowadays. So if you go to a standard tech store or computer store and you want to go buy yourself a keyboard, it's 10 to 1 going to be either USB, Bluetooth, or both of them. Now, the old keyboards, the old legacy keyboards, legacy, remember, that means something is old. Those used to be PS2. So they would normally have a little purple connector, a little round purple connector, and you would plug that into the back of the PC. And what sucked about those connectors is if you were to go and plug in a PS2 keyboard into your machine would not pick up that keyboard. It wouldn't work. You would actually have to go and restart that computer, and only then would the keyboard work. It was a very frustrating experience. And the same applied to any other form of PS2 device like a PS2 mouse. Now, as for the layout in region, guys, the layout of a keyboard is not always the same. In most countries, you'll see it looks the same to you at first glance, but sometimes that's not the case. So if you look at the letters on a standard keyboard, looking at the top left letters, it actually says out or spells out the word QWERTY. So you get a QWERTY keyboard, and that's what most of the world actually uses. Unfortunately, not all of the world uses that. Then you also get region. So my country's keyboard and your country's keyboard might visually look the same. Keys are more or less located in the same place. But you will not necessarily get the same symbols if I press the same keys, because that is dictated by your region or the language you've chosen on your computer. One such example I can give you is if you go and choose English United States versus English United Kingdom. So if you are an English speaking person, chances are you're going to choose English as your language on your computer. At least when you install Windows, or your technician is going to do that for you. Most of the time, most of us will go and choose English United States because that's the default. But it's not uncommon to see people choose English United Kingdom. In the beginning, you're going to notice absolutely no difference. But as time goes by, you will notice there is, in fact, a difference. If you try and get certain symbols on the keyboard, for example, the question mark, forward slash, backslash, comma, full stop, those kinds of symbols, you'll notice you don't always get the symbols when you press those keys. And that is because of the language or region you've chosen, guys. Believe it or not, it's the weirdest bug or glitch I've seen, but it does do that. Then we also get the mouse. And no, it's not a squeaky mouse running around your house or a warehouse or something. The mouse is a device we use to input information into the machine. It allows you to move around the cursor on the screen. And unfortunately, we didn't always have this magical thing called a mouse. It only came out around roughly 1995 when the first graphical Windows was released. So before Windows 1995, we actually had a black screen, which we call DOS screen. And the only way for us to provide input into a computer was actually to go and use the keyboard. Fun times, right? Now, luckily for you guys, we've got a graphical interface, which we call the GUI for short. That means I can see icons and pictures and folders and all kinds of stuff that I can actually go and click on. I can move my mouse cursor. Can you imagine having to use a computer with no graphical interface? Wow, that's hard to imagine, right? So the mouse, guys, also comes out on USB or Bluetooth. That's what most of us will use these days. And yes, back in the day, they used to be PS2. And actually, we did actually have something even before PS2. Hard to believe. Mouses can also be optical or laser designs. And back in the day, we had like a ball underneath the mouse. You know, can you believe it? So I'm not sure if any of you guys go back to that far. It depends on how old you are. But depending on how old you are, you might still remember the good old mouses that did not have a light underneath it. You know, some sort of laser or optical. Instead, it had a ball underneath it. It was a real mission of note to clean those. So normally you had the ability to go and take the ball out. You had to clean them from time to time, put it back in, and God forbid, if you were trying to play something sensitive like a computer game, yeah, it would really let you down over time. And then, guys, if you have the right mouse and you're willing to spend a little bit extra, you could potentially get yourself a couple of extra buttons. The scroll wheel will do certain functions other than the normal functions. So besides the normal left click and right click button, you'll have a couple of extra buttons on the left or the right of the mouse that does, well, extra functions on your machine. Alright, and then moving on to Bluetooth, something we did briefly mention with regards to keyboards and a mouse. So Bluetooth, guys, I think one of the first places we probably started seeing this was probably on the very first color screen phones. So for me, that was around 2003, 2004 is when I started getting my first color screen phones. Kind of starting to give away my age here. And I remember back then, the only main thing we really kind of used Bluetooth for was to send a song from one phone to another, because back then that was when the first phone started being able to play what we call true tone. Before that we had monotone and polytone, which was very sucky tunes, or ringtones as they would call it. And then true tone was when you had the ability to go and use an actual song as the ringtone of your phone. It's kind of funny because back then, since it was a new thing, everybody wanted to have this ability. And nowadays, any phone, even the cheapest phone you buy, has that ability. And now we're actually going back to the old school tunes. You'll find a lot of people don't actually use songs anymore. as the ringtone because, well, it's annoying. So we're kind of moving away from that now. So yeah, Bluetooth could be used to send something from one phone to another. Definitely not as slow as it used to be back in the day. Absolutely not. And yet we use it for everything but to connect two phones to one another. These days you'll find someone will use Bluetooth to connect their phone to their car so they can communicate hands-free while driving. You'll connect your phone to maybe an audio system in your house, maybe one of these Bluetooth boom boxes, maybe you'll connect it to a Bluetooth headphone or headsets. Lots and lots of goodies you can go and do it with. So Bluetooth, guys, is basically an example of a personal area network. A PAN, in short. That, guys, is the smallest kind of network you get. So anything that's basically within arm's reach, that's part of your personal space, is part of your personal area network. So you can imagine having a desk in front of you, even if it's a big desk, that's fine. And if you've got a laptop or a desktop on a desk, and you've got anything that's basically within arm's reach that you plug in directly on your machine, that'll be part of your PAN, your personal area network. So if I connect a printer via cable or wireless, if I connect the screen via cable or wireless, my phone via cable or wireless, that all forms part of my PAN. So if I connect my phone wirelessly via Bluetooth, something else like my car, that'll be an example of a personal area network. Now, with regards to a PAN network, this is wireless communications which enable short-range connections to peripherals and networks. So that's a short description of that. Now, with regards to Bluetooth, guys, if you go look at the manual for this course, they'll tell you it goes up to 10 meters. I have, however, seen that it can actually go sometimes way further than that. I've seen this go up to 100 meters or even more, but it all depends on what kind of Bluetooth you've got on your device. It depends on whether you've got line of sight. If there are things in the way, what are these things? Are they made out of metal? Are they made out of wood? How thick is these items? So there are items to consider here. Are there other things in the area that causes interference, perhaps? So yes, Bluetooth does go through items like through walls, but how far you'll get with that, well, that depends on how thick the wall is and how many walls there actually is that it has to go through. You know, that's going to dictate how strong the signal is when it comes out the other end. But it does, luckily for us, not need line of sight. Now, still on the topic of wireless communication, we also get something called RF and near field communication, which we normally just call NFC for short. NFC has actually become very, very popular these days. And you'll be surprised to know how commonly we use this. You just don't realize using it. Now, starting with RF, that is short for radio frequency. So guys, to give you guys a couple of examples of where we might use this could possibly be passive tags. Typically, they are encoded with data. So if you've got some sort of tag that you will go and tap or swipe somewhere that allows you to open a door or a gate or a boom gate of some kind, well, that could be an example. They respond when scanned by an RF reader, and they are also very widely used for inventory management if you are in that kind of field. Now, as for the NFC side of the coin, well, guys, if you have a banking card, you'll find that a lot of these banking cards have what we call tap and go, or just tap, which means you do not need to insert the card into a device like a PayPoint or a SpeedPoint to be able to do your transaction. Instead, you just bring it near the device or tap on the screen somewhere, and voila, the transaction will go through. That is called near field communication. Now, a lot of phones, if not all phones, have that these days as well. So instead of using an old conventional banking card, you can actually load a digital banking card on your phone, and you can actually make a transaction using your phone instead. It's not limited to phones. You can actually find these on some of these new fancy smartwatches. I've seen them sometimes on little rings. If you've got the right ring and you've got enough money to go buy one of these rings, even those kinds of devices come with NFC. So if you bring it near the pay point, the transaction is going to go through. So it's peer-to-peer version of RFID working at very close range. And normally you need to almost touch the device to get this thing to work. And it can be used on smartphones with contactless payment. Obviously, it's not limited to smartphones, but it can be used on smartphones. And that's probably one of the most common places you'll see it besides your good old-fashioned conventional banking cards. Right, folks, and then just a little bit more about networking interfaces. I know we briefly did talk about this earlier. We talked about wireless and wired. And I gave you guys examples of that. So we're just going to touch on that briefly, quickly again. It is very important. So under network interfaces, first thing we want to mention, network interface cards. Now we did explain earlier in this video what that is. That is short for NIC. It's the actual card in your laptop or desktop which allows it to connect to a network via wired or wireless connections. So this is normally on board. It's normally built into your motherboard. This applies to both laptops and desktops. But you can go buy expansion cards, which will give you a new or an additional network port. This is more common on desktop PCs. It's not really possible on laptops since, well, laptops don't have expansion ports. So this can come forth in expansion cards, like I just said, not something you'll see on a laptop. Normally with a laptop, you're stuck with what you have. So on a laptop, the only things you can change or upgrade is normally the hard drive. You have to replace it with a bigger one. You can't just go and add additional ones because there's no space. And you can, if you're really lucky, you can go and add additional RAM chips. Sometimes even that is not possible. Now, as for the actual cables themselves and the connector, we did mention that earlier as well. It's called an Ethernet cable with an RJ45 connector. That Ethernet cable, guys, is just a category of cable. Ethernet does not necessarily mean it's a LAN cable. It's just a category. So Ethernet includes things like LAN cables, fiber cables, coaxial cables. Not something you need to know or worry about at this point in time. So an Ethernet cable is just another way of saying it's possibly a LAN cable, and those cables use RJ45 connectors, and they go into an RJ45 port. So that's the port on your laptop or desktop where you would plug in your good old-fashioned LAN cable. So we call that a patch cord. Some folks call this a fly lead. It's got an RJ45 connector. That's going to be between your network interface card and the Ethernet switch or the wall port, assuming there's a switch or a wall port. Then, guys, a cable we have not mentioned yet in this course or this video, a telephone cable with an RJ11 connector. Now, for those of you that still have access to one of these old telephone cables, the old conventional telephone cables, which are probably considered legacy now, if you look very closely at the connector on one of those old telephone cables, and you compare that to a LAN cable, you'll notice at first glance, they look the same. Except the telephone cable's connector is a little bit smaller and it does not have 8 copper connectors. Instead, it's got 4 copper connectors. That, guys, is an RJ11. So a telephone cable uses an RJ11 connector, and a LAN cable, Cat5, Cat6, those ones, they use RJ45 connectors. You need to remember that for the exam, guys. That's going to be a question in the exam. Now, a telephone cable, besides being called a telephone cable, these cables are also sometimes referred to as a POTS line. POTS, which is short for plain old telephone system. So the cable itself can be called an RJ11 cable, but we don't normally call it that. We call it a POTS line, or we call it a telephone cable, or we just call it a digital subscriber line in some cases. But I think the more common name you'll see is a telephone cable or a POTS line. So these all telephone cables and connectors, they are smaller than RJ45s and fewer wires. So it's got 4 copper connectors instead of 8. An RJ45's got 8 connectors and there will be 8 wires. A telephone cable's got 4 connectors, but it does not mean there are 4 wires. Many telephone cables actually in fact just have 2 wires in them or 3 wires, depending on how many telephone systems you want to connect and how you want to go about connecting them. So just because there's 4 connectors, folks, does not mean you're going to be using all 4 of those connectors. So that's a different field of expertise. Alright, so these cables, they are used for dial-up analog modems, not something we use anymore. They can be used for fax modems, also not something we really use anymore. And they used to also be used between digital subscriber line, internet modems, and a telephone jack. So if you've got good old school internet, ADSL, DSL, those kinds of internet, you would normally have to have a telephone line, which would have to be installed in your office or your home environment. And in some countries, you would normally have to pay a monthly line rental fee for that telephone cable. And that's effectively what you would use to connect to the internet. Unfortunately, if the telephone lines are down, that means your internet is down. And the speed was really not that great. So these days, you'll find a lot of countries are using fiber and various forms of wireless and all that, which are way faster communications when it comes to internet. Alright folks, believe it or not, that brings us to the end of Unit 2. We are now moving on to Unit 3. Remember, there's 5 units in this course. We're moving on to Unit 3. Unit 3 is called Using Peripheral Devices. Alright folks, and then the very first topic in this unit is installing and uninstalling peripherals. So these days, these peripherals can be anything. It can be your mouse, your keyboard, printer, scanner, webcam, you name it. Almost anything you can connect to your machine these days is considered a peripheral. And when I say machine, that could be your laptop or your desktop. So the first kind of installation I'm going to talk about is plug and play installation, which is the more common one we use these days. So considering that most devices are USB these days, you just plug it into the respective USB port, you wait 1 second or a couple of seconds, and voila, you're hot and ready to go, the device will work. So plug and play means literally you just plug it in and you go and use it, kind of like the name suggests. So in these situations, Windows locates and installs the device driver, assuming there actually is one that's needed, and it will automatically establish the connection to this device. These devices are also hot swappable devices, which means you do not require to disconnect the system, restart the system, anything like that. So about 10 years ago, 15, 20 years ago, devices were absolutely not hot swappable. If you look at something like a PS2 device, those devices you normally had to go and plug a mouse or a keyboard or whatever in first, restart the device in question, and only after a quick restart would this device be detected. That was a real frustration, especially if you needed this device immediately. But now you have to go and restart the computer first. What a frustration. Can you imagine having to go back in time to that kind of fiasco? It would be a real train smash. So yeah, the old way of doing things will probably be the manual driver installation. Unfortunately, we have not quite fully moved away from that yet. There are quite a few devices these days that still requires us to manually go and find the driver and manually install the driver. So you're going to have to go and manually locate the driver setup file, wherever it might be. Maybe you've downloaded this from the manufacturer's website, and then you are, of course, going to have to go and manually install the respective driver. Now, speaking about installing drivers and devices, you guys are also going to have to know how to go and uninstall or remove drivers and devices. So the way we most commonly do that, when it comes to actual devices, hardware equipment and stuff that needs to be uninstalled, the most common place we do that, folks, is Device Manager. This is something you can find both on the client operating systems like Windows 10 and 11, and you can also find this on the server operating systems like Server 2019, 2022, and so on and so forth. So what do we use Device Manager for? If you look at the picture, Device Manager, guys, doesn't just show you all the hardware components installed in your machine. It also indicates whether a driver has been installed and if it's in fact the correct driver. If need be, you can use something like Device Manager to completely uninstall a driver. So if you or the user have installed an incorrect driver, or even in cases where the operating system have installed incorrect driver, you can in fact go to Device Manager, go to that specific component, go to Properties, and then you go click on the Driver tab, and there you'll be able to go click on a button that says Roll Back Driver. Now, Device Manager can actually also be used to check the properties of devices. You can go and check if they are installed, if they're not installed yet, if they're disabled, enabled, all kinds of jazz like that. And if need be, you can even come in here to go and scan for undetected devices. So if you've got a device and you know for a fact it's plugged in, but it's not exactly being picked up, you can come in here. It's going to show you this device. You're just going to see like a yellow exclamation mark on them, which means your computer doesn't know what the heck they are. That's why the driver has not been installed. So these days, most of the time, Windows will install the drivers automatically, but there are going to be cases of some weird new devices where Windows just does not know what the heck it is, and then it doesn't install the driver for those devices, and you're just going to see a yellow exclamation mark in Device Manager. Now guys, moving on to a little bit of a different topic, IP-based peripherals and web configurations. We're kind of sort of talking about peripherals, but now we're talking about IP-based peripherals. So in case you're wondering what the heck this is, this could be something like your router in your home or your office environment. It could be one or more access points if you're so lucky to have those kinds of things. It could be a switch, a network switch if you know what those are. It could be a network firewall if it's an actual physical firewall. These are all examples of IP-based peripherals. So should you be so lucky to have one of these devices, you would normally go and plug them into the network via a network cable or something in that line. Once you've done that, you're going to go to a computer that's on the same network. It doesn't help you just go to any computer. It has to be a computer that's actually on that same network. Once you've done that, you open a web browser on that computer. You go to the address bar where you would normally go and type in www.whatever you want to go to. And instead of doing that, you are going to be typing in the IP address of the peripheral that you wish to connect to. So if it's something like an access point, you're going to type in the access point's IP address, which is probably going to be 192.168.1.1 or .0.1 at the end. Once you've done that, you're going to land on a page which looks like a web page, but I assure you it's not. It's the portal or the landing page or the splash page for that device, where it's normally going to ask you to log in. It's generally going to ask you for some sort of username and some sort of password. Assuming it has not been changed yet, it should be on the default factory spec, which is normally admin as the username, and the password will normally be blank, or the password will either also be admin as well. Could possibly be something else, but it depends on the brand and the make and the model. But generally, from my experience, most devices have admin as the username by default, and the password will either be blank or the password will be admin as well. In some cases, you might find the password will be admin at 123 or just admin 1234, something in those lines. So what you guys see in front of you is an example of what it may or may not look like when you log into a device. So this is a TP-Link. That's just the brand of this device. So that could be an access point or a router. And once you've logged into your respective access point or router or whatever you've logged into, you'll find that no two of them looks the same. Unless you buy the exact same make and model and stuff, it's not going to look the same. I mean, me and you can have the exact same make, but just two different models, and I can tell you now, it's not gonna look the same, guys. But the concept is still the same. So if you can log into one, and you've worked on one, you can normally find what you're looking for on the next one, because the concept will always be the same. Moving on to what we call display devices. So that, in case you don't know, and I'm sure you guys can guess what this is a device that displays what the heck is going on your computer. So in other words, a computer monitor. If you're using a desktop computer, it'll be your desktop screen, your desktop monitor. 19-inch, 22-inch, 24-inch, depending on how much money you're willing to throw at this. That would be an example of a display. Those are commonly referred to as flat screen displays. If you're using a laptop, it kind of sort of also has a flat screen display. I mean, if you look at that screen that's built into a laptop, technically, that'll probably be a flat screen display as well. I mean, it's very small, but it's technically flat screen if you think about it. You can, in most laptops these days, plug in an external screen. So if you've got a desktop computer monitor, usually you can actually go plug that into your laptop as well. You can even go and plug in a TV screen into your laptop or your desktop computer these days. All of them are examples of displays. And these days, all of those will actually be examples of flat screen displays, because you don't really get a screen that's not flat screen these days. What you do get these days, though, is some screens which are in fact touch screen. Now that's more common on laptops. So if you've got enough money to throw at a laptop, you might be lucky enough to get a laptop that's got a touch screen display. Doesn't mean the keyboard doesn't work. You would normally still get a keyboard, but you can in fact actually touch the screen on the laptop too now. I'm not a big fan of those, to be honest, because normally my screen will be dirty. For some reason, the screens are always dirty. Now you do get computer screens out there for desktops as well, which are actually touch screen, not something we use commonly. It's more common to find these in places like coffee shops and restaurants and stuff, where the waiter or the waitress has got to go and place the order very quickly. Instead of using a keyboard and mouse, they'll just go and touch on the screen, boop, bop, beep, boop, bop, here and there, and then, yeah, they just get the job done quicker. And then, folks, we get something called a projector. Chances are, somewhere along the line, one of you guys would have seen these. You might have even worked with them. So normally these are used in boardrooms, conferences, meeting rooms, those kinds of things. It allows you to project what's on your screen onto a wall or a projector screen. So a larger audience. It's not just you or one or two other individuals. It's so that a much larger audience can see what the heck is going on your screen. So you can choose to have the projector display exactly what's on your screen, or you can go and choose an option on your computer that says extend my desktop, which means what they see on the projector is not necessarily what you see on your laptop or your desktop screen. You can have them see something else. So it all depends on how you set that up. Which shortly brings us to the next option here, display settings. Not exactly what I want to talk about. But we'll get to that in a second. So with regards to display settings, guys, what this menu will look like depends on whether you're doing this on Windows 10, Windows 11. It depends on how up to date your Windows is, what build you're using, what edition you're using. But in a nutshell, it involves normally right-clicking on the desktop. Normally, there'll be an option in the drop-down menu that says display settings or something close to that. It'll present you with a menu like kind of what we see in front of us. And there you'll be able to change things like your wallpaper. You can go and change something, some other built-in wallpaper. Or you can go and choose something custom. You can go and choose the colors or the theme of your windows. You can go and choose when and how your windows locks. If you are nearsighted and you need glasses and you want the font to be larger, you can go and change those kinds of things. Basically, in a nutshell, what I'm saying is you can go and customize your windows here. Speaking of customizing windows, here we've got screen resolution. So what exactly you will have here as an option depends on the size of your screen. It's not just dictated by the actual physical size of the screen, but it's also dictated by, well, the performance and the quality of your screen. I've seen some pretty big screens that doesn't have high resolution, and then I've seen some pretty small screens that actually does have high resolution. But generally your chances are higher, pun intended, higher for a higher resolution if you've got a bigger screen and it's a high quality screen. So the higher the resolution is, the more pixels there will be, which means the image quality is just going to be so much smoother, so much more detail that you're going to be seeing. It's not just going to be pixelated, it's going to have a lot more detail in it, guys. Now on this very same menu, you will notice you can also go and change other things like screen brightness, should you want to go and do that. And often you can even go and choose whether you want to extend your desktop here or just duplicate your desktop, something I did mention with regards to the projector. Now, speaking of extending and duplicating your desktop, that brings me to this topic, guys. Installing and configuring dual monitors. Now, I do want to make it clear that when I say dual monitors, it's not necessarily 2 or more computer screens. It could very well potentially be a computer screen and a projector, because technically that is a monitor if you think about it. It does still show technically what's going on the computer. So technically it is still technically a monitor if you think about it. So if you have just a laptop and that's it, you've not plugged in any external screens, you would have just a monitor, the one that's built into your laptop. If you've got a desktop PC, you just have your one standard computer screen, you would just have, well, one monitor. But you do have the ability to go and plug in one extra or even more than one extra computer monitor into your desktop as well as your laptop. It's more common to see people doing this on a desktop computer, but it's not that uncommon to see it on a laptop. On laptops, however, we normally do this only to, well, plug in a projector normally to display to an audience of some sort, maybe in a meeting of some kind. Now, options we've got available is to go and choose duplicate. So if you've got 2 or more screens, if you choose the duplicate option, which is the default normally, that means what you see on the one screen will be exactly the same on the other screens. So that'll be this first picture you guys see on the screen. It's got a 1 and a 2. That means everything is exactly the same on all screens. When you've got 2 or 3 screens, it's exactly the same on all screens. Another option you could potentially go and choose is to go and click on extend. Extend means you've got a much bigger desktop. So what's on the one desktop on the one screen is not the same as the other screen. So you can actually drag a window or a program from the one monitor over to the other monitor. It's literally like you've got a much wider desktop, which is why it says extend. And then the last option, which generally only works for projectors, just in case you're wondering, is to project. So project, show on one screen only, and that's going to go and project. Now we've talked quite a lot about, screens and monitors and resolution and all that, but what about audio? So with regards to audio, guys, you also get audio settings on your Windows. And yes, you do get this on server operating systems as well. It's not something we normally go and play with on a server, because why would you want audio on a server? This is something you can expect someone to go and play with on a client operating system, something like Windows 10 or 11. So yes, you can go into the audio settings. It will look more or less like the pictures that I'm going to show you guys here on the screen, but it might possibly look different because some computers do have their own motherboards that do come with their own specialized custom audio software. And that normally gives you all kinds of extra cool functions and features and configurations you can go and play with. But the pictures we see on the screen is more or less what you can expect to see on your standard Windows operating system. So that will be your sound applet, which can be found in the control panel. So if you guys go dig around your control panel, you'll find what we call the sound applet. And there is one of the places you'll have the ability to go and control volume for devices. If you happen to have more than one audio device plugged into your computer, maybe more than one set of speakers, or speakers and headphones, or speakers and earphones, or whatever, you can go and choose which one needs to be the default. By default, how it normally works is, if you've got speakers plugged in, that will be the default. And should you plug in earphones afterwards, that will now be the default until you plug it back out, then it will automatically switch back to speakers. Unless you choose otherwise, you can actually go and force it in the menus to switch over to the other one without having to plug out the previous one. We also have something called webcams, guys. I think we all know what those are. So I'm not just talking about the cameras built into your phone these days and your tablet. I'm sure you guys would have seen almost all laptops have a webcam built into the computer screen. Now, you don't have to go and use those, although most of us would, because why am I going to go and buy something if I have it already? So the only reason why people would normally go and buy another webcam besides using the one built into the laptop screen is because the laptop screen one is not normally the highest quality. So if you want very good, crispy, clear quality, 4K or higher possibly, maybe you want to go and record a video for YouTube, kind of like what I'm doing right now, then maybe you want to consider getting yourself a higher, better quality webcam. As for those folks using desktop PCs, most of those guys normally have to go and buy themselves a webcam either way because most desktop PCs don't come out with a webcam. Unlike laptops that have them built in, desktop PCs natively come without webcams, so you're going to have to go and buy one. It sucks, but it is what it is, guys. So it's a compact video recording device or a video streaming device, or quite frankly, just shows you what the heck is going on. Once upon a time, they had very low quality, these modern webcams, but nowadays we're lucky enough to have them in very high quality if you go and buy aftermarket ones. The ones built into laptops, they're getting better. I mean, I'm not gonna lie, they are getting better, but they're not that great yet. These can be built into laptops or attached via USB, something I did mention to you guys already. And on that note, I'm gonna move on to the next topic, which is the last topic for Unit 3, printer types. Now, in this unit, or should I say this course even, in ITF, guys, we actually just talk about two kinds of printers. We talk about laser printers, and we talk about inkjet printers. Those are the only two that we mention in this course. It's the only two you need to know for this course and for the exam. But I do want to point out that, yes, you do get other kinds of printers, and yes, you do need to know them for the other courses. If you go look at the next course after this one, which will be the CompTIA A+, there we don't just mention laser and inkjet printers. There we also talk about impact printers, 3D printers, thermal printers, just to name a few. There's quite a few printers out there, guys. But in this course, the only ones you need to know is laser and inkjet printers, which are actually the two most commonly used ones. So if you are in a home environment or a very small office environment, it's probably going to be an inkjet printer most of the time because they're cheaper, or at least cheaper to buy, but the maintenance cost is way more expensive. And if you are in a little bit bigger than a small office environment, maybe a medium to a large size company, you're 10 to 1 going to be using laser printers. They normally print a heck of a lot faster. The upfront cost to buy these little buggers is a little bit more expensive, but trust me, maintenance cost when it comes to ink is way cheaper. So laser printers, they use something called toner. It's like a powder kind of ink. And inkjet printers, they use liquid ink. Yep. Now, normally how these printers work, whether you're using the powder ink one, which is laser, or the liquid ink one, which is inkjet, either way, they normally use 4 colors, and by mixing these 4 colors, it's able to get all the colors of the rainbow. So you can go and choose grayscale, which forces the printer to just go and print in, well, black for the most part. Or you can go and choose color, which means it's going to go and use blue, which they refer to as cane, magenta, which is the old pink, yellow, which is yellow, and black. It's going to go mix these 4 colors, and you're going to get all the colors of the rainbow. Alright, folks, and that brings us to the end of Unit 3. And now we can move into the second last unit in this module, which is Unit 4, and that is called Using Storage Devices. Alright folks, like usual, first topic in this unit, system memory. So that is something we did briefly mention earlier in the video when I showed you guys a picture of the motherboard. And one of the things we pointed at on this board was something called the system memory. At that point in time, I also told you guys that this is also known as random access memory, or RAM for short. This, folks, is your computer's temporary memory. So when you open something on your computer's hard drive, something gets stored or installed, this can be a program or a game that's now obviously been installed, or it could be a document or a file that's now been stored on your hard drive. When you open any one of those things I've just mentioned, it then temporarily gets loaded into your RAM, which is temporary memory. Now, why does this happen? Because the RAM, folks, is much, much faster than a hard drive. So if your hard drive had to feed information to your computer's brain, which is the CPU, that would take forever. Because I mean, if it had to go zigzag, zigzag between a hard drive and a CPU, it just will never get done. It's just going to be too slow. If a hard drive just can't keep up, it's not going to give the CPU the information quick enough, which means you're going to experience massive lag on your PC. It's going to feel like it's just hanging and like nothing is happening. So to help mitigate that, some clever guy out there came up with the idea of RAM. So whatever you are temporarily busy with, that stuff is temporarily loaded into memory, which is called your RAM or system memory, much faster than a hard drive. And eventually when you close that program, that game, or that document, it disappears from the RAM. Now, something you also need to know about the RAM, besides it being temporary memory and much faster, is it's an example of volatile storage. Now, that means if power is lost to your machine, to your laptop or desktop, anything you had in the RAM is lost. It is gone. So to give you an example of what I mean by that, imagine you've got a laptop or a desktop. Let's say this is a desktop, and you've got a program open on your laptop or your desktop, or a document or two. Now, if you yank out the power cord and the computer just turns off, any program you had open would now be closed. Any documents you had open would be, well, closed. I wouldn't say they'd be lost because it's still installed on a hard drive. That document is 10 to 1 still saved on a hard drive. So what it means is the next time you start that computer back up, you're going to have to go and reopen this file from the hard drive or reopen the program or the game that was open. So anything that was in the RAM was lost. As soon as you lose power to the machine, anything in the RAM is lost. So it does not know what was last opened, if I can put it that way. Now the hard drive, which is also storage, that will probably be an example of non-volatile, because if power is lost to the computer, anything on a hard drive is not lost. That program that was installed would still be installed. That document that was saved on a hard drive would still be saved on a hard drive. Now, since we are talking about hard drives, that brings us to this topic, hard drives. So this is one type of fixed internal storage. It's not the only type of fixed internal storage you get, but it's probably the most common kind. Like I've said earlier when we spoke about RAM, this would be an example of non-volatile storage, which means if I lose power to my machine, anything stored on a hard drive would not be lost. Watch out, guys. That's going to be a question exam. They like to ask about non-volatile and volatile storage. You're going to have to give examples or be able to identify them. Now, hard drives, about 10 years ago, 15 years ago, you for the most part just got one type of hard drive, which was, well, a mechanical hard drive. Since we only got one type of hard drive, we just referred to it as the hard drive because you literally only got the one hard drive. Now, these hard drives, the old mechanical ones, works with platters, magnets, lasers. It's got a lot of moving components in it. It's got benefits. It's got drawbacks. Now, nowadays, you'll find it's more common to find people using what we call solid-state drives. It's got no movable parts. Obviously, it also comes with its own unique benefits and drawbacks. So if we look at like a solid-state drive, and by the way, you don't need to know this for the exam or this course, solid-state drives are natively a heck of a lot faster than your old conventional drives. But they do have a limit in their lifespan as to how many times you can read and write to them. So if you have something where you're going to be reading and writing to the hard drive a lot, but you don't require speed, then I would actually in fact recommend the older types of hard drives. An example of such a situation would probably be a CCTV camera system. So if you've got a camera system, those DVR or NVR systems, they actually use normal computer hard drives. And in that situation, since you don't need speed, but since you're going to be constantly reading and writing through a hard drive, in that situation, it's better to go and use the old types of hard drives. So just to recap, the old hard drives, guys, they use what we call magnetic platters, which is accessed by a drive head. And if you can look at the solid-state drives, there's absolutely no movable parts in those. Another type of storage we get, folks, is optical discs and optical drives. Not really something we see that commonly anymore. I mean, you do still get them, and if you've got an old computer, you tend to still have one of these. But if you go to a tech store nowadays and you want to go buy yourself a laptop or a desktop, it's actually not that uncommon to find them coming without an optical drive. So you don't actually have the ability now to go and open a drive and insert a CD or a DVD anymore because they know nobody uses that. The only time you might want to go and use that is to install the Windows operating system via DVD. And even that we don't do via DVD anymore. So if it's on your own machine at home or if a technician needs to come and do it for you, he or she will 10 to 1 do it with a USB stick or a flash drive, as some people call it. Some people call it a memory stick. If it's in a company, medium to large size, they're 10 to 1 going to go and deploy the Windows operating system via network or some sort of deployment software via the network. They might even use a USB stick once again, but it's not going to be a DVD. So with regards to optical discs and drives, the old school way of doing things, these are specially formatted discs which can be read by a laser. And depending on the disc itself, some of them you can only write to it once. That's a read only. And then we had special discs which cost a little bit more, which you can go and read, write to multiple times. Not that many times, but a couple of times. They came in multiple formats. So the first most common one was probably CD, which is actually compact disc. Then we had DVD, which came out shortly after that, which was a heck of a lot bigger back in the day. So if you look at your standard CD size, in the sense of how much data you could put on it, that was approximately 700 megabits, for the average CD. Some of them had more, some of them had less, but it was approximately 700 megabits. If you look at a DVD, they were standard between 4.5 to about 4.8 gigs. Some of them could go to up to 8 gigs. Some of them were double-sided, and they could go up to 16 gigs and much more. Then we have what we call Blu-ray disc. It never really stuck. You still get these. Those were mainly used for high-quality movies. It never really caught on, in my opinion. We just kind of went straight to streaming services and all that after that. And then, of course, something I did mention earlier on this topic, these compact discs, they were recordable, which means you can only write to them once, and some of them were read-writable formats, which means you can go and write to them multiple times. And when we say multiple times, I don't mean like a couple of hundred times, guys. No, you could maybe go write to it like 2 times, 5 times, 10 times at most, and you'll see that disk is going to kick the bucket. It's not going to want to work anymore. All right, folks, and then the last topic for this unit, and then we'll move on to the last unit for this module, removable flash memory devices. First one up, which is probably the most obvious, USB. I mean, to just say USB can mean anything. So when I say USB, guys, I mean a USB stick. Some people know this as a USB flash drive. Some people call it a memory stick. It's got many names over the years. And then we also get something called a memory card. I mean, the name makes sense. It looks like a card and it's used for memory. They come in different shapes and sizes, physically and digitally speaking. Did you guys know that memory cards came out before flash drives? And did you know a memory card was actually called a memory stick before the actual memory stick was released? Yeah. Not something you need to know. It's not part of this course or even A+. That's definitely not an exam. And I bet you a lot of IT guys don't even know that. But a fact is a memory card used to be called a memory stick. But when they brought out the actual stick, which looked like a stick, well, they couldn't exactly call a card a stick then now anymore. Now, could they? There was going to be a lot of confusion. So the memory card is now called a memory card. And then a stick is called a stick or whatever else you want to go and call it. Either way, guys, these are all forms of storage you can carry around with you. Temporary storage, I suppose. They come in different sizes, capacity-wise. Very nice and convenient to go stick it into a device, copy what you need to, store what you need to, carry it to where you need to, and there you go. So it's very quick, easy, mobile ways of transporting data. And that, folks, brings us to the end of Unit 4. Finally, we can move on to the last unit in this module, which is Unit 5, using file systems. First topic up, managing the file system. So obviously laptops and desktops have what we call hard drives on them. We've talked about that in the previous module. So that's an example of non-volatile storage. Now these hard drives on their own, guys, believe it or not, they don't just work. Just because you've plugged it into the data cable and the power cable, that does not mean it's going to work. You are going to have to put on some sort of file system onto that hard drive. You're going to have to initialize the hard drive, format the hard drive with a file system, something like FAT32 or NTFS or so on and so forth, which will give this hard drive some sort of structure, and then the operating system will recognize it, and then you'll be able to utilize it and use it for storage and whatever you want to go and use it for. So in regards to physical disks and drives, that is where you're going to go and put your file system. And this actually applies to flash drives too, guys, and memory cards. Just because it's not a hard drive doesn't mean it doesn't have a file system. A flash drive can also be formatted as FAT32 or NTFS, and a memory card also has its own type of file system. If they don't have a file system, the device you plug them into will not be able to recognize them. Now, something you guys may or may not know already, if you go look at a physical hard drive, you can actually go and partition this hard drive. So it's not going to give you more storage. Instead, it's just going to subdivide that storage to make it appear as if you've got multiple hard drives, when in reality you do not. So if you've got a laptop, which normally comes out of only one hard drive, if you were to go and partition that hard drive into two, you are splitting the hard drive into two, and you can go and choose what size these two partitions needs to be. So if it's a 1 terabyte hard drive, in other words, roughly 1000 gigs, You can decide to make it straight down the middle, 500 gigs, 500 gigs, or you can go and decide to make it 300 gigs, 700 gigs. So that's still 1 terabyte. So if you go into your computer or your Explorer and you go check how many hard drives you have, it's going to appear as if you've got 2 hard drives, one that's 300 gigs and one that's 700 gigs, because you get to choose how big they are. But in reality, it's still one hard drive. It's just been subdivided into multiple partitions. So there's many benefits to that. There's obviously a couple of drawbacks to that as well. So just because you see someone with a lot of hard drives, digitally speaking, does not necessarily mean physically wise they actually have a lot of hard drives. It could in reality just be because they partitioned it. You can think of this as a pizza or a pie. So if I have a pizza or a pie and it's not been sliced yet, it's just a pizza or a pie. It's all in one piece. But as soon as I start cutting it into smaller pieces, does that now suddenly mean there's less pizza or less pie? No. It might be in sections or subdivisions, but at no point in time is it actually less. It's still the same amount at the end of the day. Now, folks, you also get something called Windows drives. These are not necessarily hard drives. They could be, they could not be. They might just be partitions of hard drives, or they could actually be an entirely different device. This could be an optical drive, could be a floppy disk drive, if you guys know what that is. It could be a memory stick, it could be an external drive. Either way, these drives normally have letters assigned to them. And your main hard drive in your computer, your only hard drive, would normally be assigned the letter C. So C is normally the letter for your main hard drive. So these Windows drives, guys, in short, are logical partitions. They could be optical drives, like a CD-ROM drive, DVD-ROM drive, Blu-ray drive, and other removable drives which can be assigned separate drive letters. So if you guys look at the picture on the right, you'll see what I mean. So there, they've got drive C, they've got an optical drive, which is the letter D. It looks like they've got an external drive, which is the letter E, and they've got a flash drive, which is the letter I. So those ones are randomly assigned by the operating system, but you can go and change them manually too, if need be. It's not something we do, but it can be done. So like I said earlier, your main hard drive, which is where you've got your operating system installed, it's also referred to as your boot drive. This contains your Windows system files. So your main one will always be C drive, folks. As for the file systems I briefly spoke about earlier, so just because you've installed a hard drive physically, guys, does not mean your Windows is going to pick it up. You might see it in your BIOS or your UEFI, if you guys know what that is. But if you go into your actual computer and you try and look for this hard drive, or you try and access this hard drive, you will not see it. You will not be able to do that. So the file system is something you're going to have to go and format your hard drive with for the operating system to be able to detect it and recognize it. You can think of this file system as lines in a parking lot. Now that on its own probably sounds very weird and very vague. So if you've got yourself a brand spanking new supermarket and outside is a brand spanking new parking lot. In the beginning, that parking lot, guys, is not going to have any parking lines on it or in it, which means cars will have no cooking clue where to go and park. It's going to be anarchy. It's going to be chaos. They're going to park each other in. There's going to be fights in the parking lot. It's just not going to work. So someone, this could be you, could be me, could be someone's going to go into that parking lot and paint some lines. Now, when you or someone does that, you're giving that parking lot some structure. The cars will know where to go and park themselves. Now, why am I talking about a parking lot and parking lines? Well, guys, when you format your hard drive, think of it as a blank parking lot. And when you format it with a file system, you can think of it as painting some lines in that parking lot. You're giving the hard drive structure so that the data, which is the cars in this analogy, so that the data knows where and how to go and park themselves on the hard drive. Yep. So partitions must be formatted with a file system before the operating system can use it. So if you have just a hard drive, it needs to be formatted with a file system. Should you decide to go and subdivide this physical hard drive into what we call partitions, like we said earlier, each and every one of those partitions also needs to be formatted with a file system. And there's no rule that says you've got to format it in the same file system. Each and every one of them can have a different file system. Not something I would recommend, but it is possible. So a couple of file systems, just to name a few, you get FAT, FAT16, FAT32, NTFS, REFS. I've just mentioned a couple of Windows ones. I haven't even mentioned file systems you get on the other kind of operating systems which are non-Windows. So coming at us from a Microsoft Windows perspective, the only ones you need to really know about at this point in time is FAT32 and NTFS. The main one, which most of us use by default, is actually in fact NTFS. So the file system, folks, it determines your compatibility with different operating systems. Unfortunately, not all operating systems are compatible with all types of hard drive or file system formats. So if you go look at Windows' latest operating systems like Windows 11 and Windows 10, generally you need NTFS. If it's not NTFS, guys, it's not going to work. You're not going to get all the benefits of Windows. It's just not going to work. It's not recommended. So Windows must be installed on an NTFS file system, in case you guys didn't know. Now, speaking about the operating system and partitions and files and folders, that brings us to folders. So folders, I'm sure you would have seen them on a computer by now. You don't need to be a tech genius to have seen a folder on a computer by now. Looks like a little envelope icon. So in these folders, you can go and store your documents, your files, or you can even go and create more subfolders. And in those subfolders, you can go and create some more subfolders. They're basically containers that allows you to organize your stuff, your junk, so you can go and find it. It's a logical way for you to order your stuff. So you can think of this as having a bunch of drawers in your home, and in each drawer you go and store different kinds of stuff. It's a way for you, or a means for you, to store different types of stuff in an organized manner. So in short, while drives store files, folders can be used to organize those files. Okay, so the hard drive stores the files, but the folders is what you use to organize those freaking files. You can go and create distinct logical areas where different security privileges will apply. So if you've got multiple folders, it does not necessarily mean any willy-nilly can go and access any willy-nilly folder. Nope. You, for example, might be able to access all folders because maybe you're the main administrator, and the next individual can only access certain folders depending on who they are and what privileges you've given them. And here below, subfolders and file paths, I've given you guys a couple of examples of what it might look like. I suppose you can call these breadcrumbs. So that's basically what it would look like when you go into a subfolder, a sub-subfolder, and a sub-sub-subfolder. I mean, if you look at the first one there, where it just says C, there I'm on the hard drive, but I haven't actually gone into any folders yet. And in the middle one, it says C Windows. There I've got into the first folder, which was obviously called Windows. And then the bottom one, I've got into two folders. I'm 2 folders deep. And you can really go 20, 30, 50 folders deep if you really want to. Moving on, still kind of on the topic of folders, yes and no. Now we're talking about something called File Explorer. I might have mentioned this in module 1 or 2. I can't remember, it's been too long. So File Explorer, folks, is what we use to, well, explore your files, your computer. It's what allows you to browse the graphical user interface on your machine. So the fact that you are able to go into folders and documents and browse the machine and see your desktop and icons, that, guys, is all File Explorer. So if you were to go and kill that process in the back end, yes, it's a process, you'll notice immediately you can't see any folders, no files. You'll literally just see the wallpaper on the desktop. That's all you will see. You'll see absolutely nothing else besides the wallpaper on the desktop. So you will in fact have to go and restart the File Explorer. The service is actually just listed as Explorer. In some Windows it'll be listed as Windows Explorer, sometimes File Explorer, but I've seen more commonly it's just listed as Explorer these days in your task manager. So yeah, it allows you to see your documents, pictures, videos, music, and any other folders and stuff you might have made. A couple of pictures on the right hand side of what you may or may not see. And then, folks, when it comes to deleting files and also your recycle bin. So when you delete files, in other words, you just right click on a file or a folder and you click on delete, where does it go? Recycle bin. When you click on a file or a folder and you just press the delete key on your keyboard, where does it go? Recycle bin. But there's a but here. If I click on a file and I go and hold the shift key down and I press delete, what happens then? Where does this file go? Nowhere. It skips the recycle bin and it's just permanently deleted. So that's a way or a means for you to delete something permanently without it going to the recycle bin. Now, just because something is in a recycle bin does not mean it cannot be deleted permanently. You can actually go into a recycle bin and then empty the recycle bin, which means then you cannot restore it. Or you can just go and, well, restore an item from the recycle bin. So if you want to delete something, but you're not quite sure yet if you want to restore it maybe later, I would suggest send it to your recycle bin for the time being. But if you want to delete something and you know for a fact you do not want to be able to restore this once upon a time in the future, then you can go and hold the shift key down while deleting the item in question. So in short, guys, deleted files are normally kept in a recycle bin unless you empty the recycle bin or unless you hold the shift key down. Recovering files and emptying the recycle bin, so that can be done if you go into the recycle bin. There you'll be able to enter the recycle bin, which deletes those files in there permanently, or you can just go and select the file you want to recover, assuming it's still in there. And if you want to erase a file, in other words delete it permanently, that can be done by pressing shift and the delete key at the same time, and not just the delete key on its own. Alright folks, and then the last topic for today in this module, and don't disappear after this topic, I want to mention a couple of things. Folder and file permissions. We did briefly mention that earlier when we spoke about folders. So when you make folders, guys, and even on files, you can right click on a folder on Windows. This is one of the benefits you'll get of the NTFS file system. You can right click on a folder and you can choose who can access that folder. Only certain individuals or only certain groups of individuals. So this is normally what we call privilege on a Windows machine. It can be done on a client operating system like Windows 10 or 11, but it's more common to see people doing this on a server operating system where multiple people will be accessing that server and they'll be accessing multiple files on that server. So yeah, there's a bit of a picture for you guys on the right as to what that will look like. So this could be a matter of access denied. So if someone tries to access something they're not supposed to be accessing because you've denied it, then they're going to get an access denied message. And to be able to configure this, you've got to go and right click on the document or the folder. You're going to go to the security tab. That is considered your NTFS permissions. Should you go click on a tab that says sharing, that'll be your sharing permissions, folks. And if you want to know more about this, this is something that will be covered in A+ in way more depth. And A+ I actually give demonstrations on this. But what I've just mentioned, that's actually all you need to know for this course. Anything more will be A+ level. It's not something you need to know for this course or the exam. Alright folks, that brings us to the end of Unit 5 and to the end of this module. Thank you for watching this video. Please give this video a like, help a homie out by doing that so I can get this video in front of more people and help a lot more people out there. If you feel this video has helped you, or if you'd like to know when the next module comes out, please consider subscribing to the channel. And just to mention it, if you also want to sponsor this channel in some sort of way, you can find that information in the video description down below. So guys, special thank you to all the Patreons of this channel. So that's a platform called Patreon. So to a special thank you to all of those guys. Thank you to all those of you that's made PayPal donations. Thank you to all of you that's clicked on the thanks button below the video. For some people it will be available, some people won't. And also thank you to those of you that just bought me a coffee or a milkshake. That's another option you guys can go and look at in the video description down below. So here's a list of all the Patreon sponsors. Thank you very much. And here's a list of all the PayPal sponsors. Thank you very much, guys. And then lastly, in case you guys don't know, the channel does have a Discord server. So if you know what Discord is, there's a server. It's called Free IT Training. It's a free IT community. It's got more than 1,000 people in it the last time I checked. Maybe it's a heck of a lot more now. So I'm in there. Lots of other IT experts are in there. So if you are studying this course or any other course, feel free to join that community of IT people. There's lots and lots of people in there that's studying this course as well as other courses. So if you've got a question, you can post it there. I'm sure someone will be able to assist you with your question. Maybe someone else posts a question, you can assist that person. The idea is it's an IT community of like-minded people that are studying courses like this. So you guys can share, information, study together, study groups, all that kinds of stuff. Alright folks, I will see you in Module 4 of the CompTIA ITF Plus course. Enjoy!